All right, inverse functions, okay? Inverse functions are denoted by this little notation here, f to the minus 1, okay? Which means the inverse of a function f. Okay? F to the minus 1 does not represent an exponent. The inverse of a function can be found by interchanging x and y values of a function. Okay? The graph of f minus 1, or f inverse, right, is the graph of f reflected in the line. This is kind of the cool part of this. Y equals x. Yeah, it's pretty interesting. And we'll draw this on there. Okay? So for the very first example, if you're just given a list of coordinate points, right? It'd be like a relation that happens to be a function based on points, right? So what you can do is follow the definition. Inverse of a function can be found by interchanging the x and y values of the function. So here's what we're going to do. F inverse is going to be, there's a little squiggly bracket again, okay? 8, negative 2, careful, negative 2 and 0. Be careful when you do this, you don't like just gloss over any of them. Make sure you flip all of them. 4 and 3, and 7 and 4. Okay? Now, one other thing you might choose to do here is just write the x values in like ascending order. So something from like smallest to largest, right? The x values. So that you can just graph them. So it's not just a jumble of points. You can kind of like organize them so that you know you get every one of them and just go from in ascending order, okay, from smallest to largest. So you might want to rewrite this to be like just order the x values. So negative 2, 0, 4, 3, 7, 4, and 8, negative 2. Okay? Oh, squiggly. Almost ran out of room. All right, any issues? Not too bad, actually. The cool part is like finding the inverses of like common functions. That's kind of what's interesting. Okay, and we'll do a little bit. There's some fun stuff that I think it's fun. I think you'll think it's fun too. I think of like what do inverses look like? Inverse functions, inverse points. It's kind of fun actually. All right. So steps to find the inverse of a linear quadratic function. Okay, the inverse of. Okay. So we have function notation. Okay. And what we want to do, like our step 1, is to kind of revert back to our old friend y equals. All right. So rewrite y equals, and that's not too unfamiliar. It's just we know f of x and y are interchangeable. So y is equal to 2x plus 4. And what I'm about to show you now is the whole reason why we did things in the order we did today. Okay, what we're going to do, step 2, is interchange x and y, much like what we just did with the points. So that just means x is equal to 2y plus 4. Everybody see what I did? I interchanged x and y, just like the instructions told me. Now, an equation typically is not x equals 2y plus 4. How have been all the equations you've seen? Y equals, right? Typically. So what I want you to do is rearrange that to give me y equals. Give me the equation in terms of y equals. So just rearrange what's on the page and basically solve for y again. Okay, so to do that, I'm going to go like this. I'm going to subtract 4 from both sides again, just like what we just finished doing. Okay, we're going to get something like x minus 4 is going to equal 2y. And then divide both sides by 2. Right? And so you might choose to rewrite. Sorry, we'll write it like this. Here, I'll shoot up here for a sec. We're going to go y is equal to x minus 4 by 2. You might choose to write it like that, or you might choose to write it like this, because it's easier to graph. Does everybody agree? What I've got up there? And I suppose the very last, sorry, one extra little final step, sorry. Put it back to this function notation, but denote it differently this time because it's the inverse of the original function. Sorry, forgot about that. Okay, now it's very clear. If you had these two functions, which we're going to plot on this grid, we're going to be very clear which one's f of x and which one's f inverse. Okay, does anybody have any issues with what just gone on? Switch x and y, solve for y, and then we're able to plot. What's going to be interesting here is I'll plot both graphs using our y equals mx plus b skills, and then we're going to see something interesting. Okay, so let's graph the first one, 2x plus 4. 2x plus 4 is we start at the y-intercept of 4, 1, 2, 3, 4, right here. And we're going to go up to right 1. So this isn't necessarily conducive to actually plotting this piece here, but let's estimate it's probably in around here somewhere. Would everybody agree? And then we could, the opposite going up and to the right would be going to go down to left 1. Down to left 1 would be here. Down to left 1. Okay, and this is where all those times that we tried to emphasize in grade 9, the labeling of graphs, that's where this is going to come into play. So it's pretty close to that point up top. Okay, now let's plot. This is our graph f of x. Okay, now I'm going to plot f inverse, the inverse of f of x. Okay, so I'll do that in a different color. Now let's say red. Okay, so we're going to plot this one in red. So we start at -2. And we have to go the slope of this one. Oh, I guess we should be doing, this is all part B here. The slope of this, m, is 1 over 2. Would everybody agree? I'm going to let everybody stare at that for a sec. There's a 1 here. 1 over 2 is the m value or slope. Okay, can we rewrite this equation? You could rewrite like this one further time. Okay, where we have a y-intercept of -2. And now my slope here, I'll get rid of this now that we can clearly see that. I'm going to go up 1, right 2. That's what that 1/2 tells us to do, because they're both positive, right? And so starting from -2, I'm going to go up 1, right 2. Up 1, right 2. Up 1, right 2 is probably over here somewhere. Oh, not quite. The opposite of doing that would be down, left, down, left. All right. And so we're going to get this. Here's our inverse function right here. F inverse of x. Now here's what here comes what I think the coolest part of this lesson, and this is the definition of, or a piece of the definition of what an inverse is. Right at the very top, we said just to interchange the x and y values, we find the inverse. But the cool part is, an inverse function of its original is a reflection in. This was the other definition that we wrote down. Reflected in the line y equals x. So what I'm going to do here is let's plot this y equals x graph. That's like a y-intercept of 0. It doesn't have a y-intercept, right? Y equals x. It's 1 over 1 x plus 0. That's y equals x. Would everybody agree? So as a y-intercept of 0, and then I'm going to go up 1, right 1, up 1, right 1. So let's see what the kind of interesting piece is here, okay, when I plot that. So here's my y-intercept. Okay, and let's plot this like y equals x line. So you'll see that the red graph is a reflection of the black one about the blue y equals x line. You reflect over it. So they're symmetrical about that line. Would everybody agree? That's kind of cool, I think. Right? And as the graphs get more complicated, like those graphs that you would have seen on Friday, all those parent functions, the absolute value of x and the parabola and the hyperbola and all those, if you find the inverse of those, you get some interesting things happening. All right? Does anybody have any questions so far? Just remember, it's always like there's two parts of this, right? You're interchanging x and y, right? And then it's also a reflection in y equals x. Those are the kind of two parts of this inverse conversation. All right. The second part here is, it asks us the question, is the inverse a function? So let's think back to like day 1 or day 2. Do you think that this red graph or inverse that's been labeled, do you think that's a function? It is a function, right? I think, right? Because if we were to put our vertical line test on there, it only ever has one y value for any particular x by definition. Okay, so that's a function. All right, so yes, it is a function. And then you could provide a little detail as it passes the vertical line test, which you know as being a fancy or abbreviated way of saying for every x there is only one y. That's what the vertical line test tells us. Okay. Everybody happy? Would you get full marks for that graph sitting there? What are you going to get hit with on IB? Yeah.
The labels for the x and y.
The labels for x and y, all right? Okay, another thing, the arrowheads. Unless the question gives you a specific domain in which the function exists or something like that, you better include the arrowheads because that implies it goes on forever. If they don't specify the domain, you better have arrowheads to show that it goes on forever. Does that make sense? That's kind of cool that we can have that conversation now about domain. Yeah, Max?
Didn't it also ask you to label the line of reflection?
Oh, fair enough. Yeah, see, wouldn't have gotten full marks there. So y equals x. There you go. There you go. That's at one scale, I think. Even some of like the 9s. Make sure. This is my lesson. I didn't even read the question. I haven't done it in a while, but make sure you read the question and answer everything that they ask you for. Okay? There's obviously, if it's been asked, there's a mark allocated, and so if you don't answer it, can't give you the mark. Okay? There we good? Good recap, I think. All right. Let's turn the page over. Okay? We'll take a look at these two, and then that's honestly it. Alrighty. So it told us here, we've just got a function, a series of points here, order points, right? And so y equals f of x, here are your points. So in this table, we're just going to write down the points. All right, so we're going to get negative 3, 1, negative 2, 1, negative 1, 1, 0, 3, 1, 0, and 1, 2, 3, 4, negative 3. There we agree? All right, now we're going to find the inverse. So the inverse is going to be flip the x and y values. Okay, so we're going to get 1, negative 3, 1, negative 2, 1, negative 1, 3, 0, 0, 1, and negative 3, 4. Okay, and we could reorder those if you wanted to and plot them. We'll plot them in a different color. Okay, we'll go negative 3, 4. Try to make it neat. What comes next? So 0, 1, 1, -1, 1, -2, 1, -3, and 3, 0. Okay, so we can go plot those. That just makes your life easier in terms of plotting, right? So -3, 4 is going to be here. Okay, 0, 1 is going to be here. 1, -1 is going to be here. 1, -2 is going to be here. 1, -3 is here. And 3, 0 is going to be here. It's kind of cool. Can everybody see the symmetry in that? Symmetry about this line here. It's pretty interesting. It's just a reflection in that line y equals x, right? Now, again, ask this little question here, so we need to answer this. Is the inverse a function? The inverse is going to be all those red dots that I drew. Okay, hopefully we're shaking our head no, right? Because it looks like there's an instance where for some particular x value, in this particular instance it's 1, at x equals 1, we have 3 y values, right? So it doesn't have, for every x, we have 1 unique y. At x equals 1, we have 3 y values. So that's not a function. It breaks the definition. All right? So no. All right? Are we happy? You could do this next question one of two ways. You could develop the equation of this line. Right? You could give me like y equals whatever it is. Okay, y equals negative. Actually, you could look at it and figure it out. You know it starts at what? Positive 3. And how do you move from this point to this one? You go down to right 1. So negative 2x plus 3. That's how you would come up with that. You could do that and then flip these around and solve it. But I don't think you need to do it that difficult, right? I don't think it's difficult. It's just way more work than I think it needs to be, because you could just identify, here's 2 points on the line, write down what those points are. So we know if g of x is going to have an x value of 0, what's its y value? Well, it's 3. And then it has a x value of 1 and 1. And so g inverse of x is just going to be a flip-flop of it, right? I don't think you need to do what we did on the front side of the page. Okay, it's too much work. You've got points there. Just flip them around. 3, 0, 1, 1. Oh, that's kind of an interesting one. So let's plot those points. Okay, 3, 0 is going to be here, and 1, 1 is still there. And it looks like it's still a reflection in the line y equals x. Okay, is this one a function? This one's a function, right? Because it still has, for every x, there's only one y. Okay, so yes. Let's find some room. Yes, g of x. Sorry, g to the minus 1. I just finished doing calculus. That's something else. Careful. Make sure you got minus 1. Alrighty, we'll hit stop there.